Hello. In this video we're going to look at how to find a trigonometric equation from a graph. Now, the question is the following here. Find an equation of the form y equals a sine quantity bx plus c quantity plus k. But I want to make a point that, take a look at this graph carefully. It goes from 1 to 3, right? And it looks like it goes from -6 to +6. This is the same graph. I have it down twice because I want to make the point that really you have an infinite wave here, and you could find as many sine and cosine equations as you want. So for example, let's say I'm looking at sine. Well, I know the basic shape of sine is either like this, right? And it wraps around an axis. So the sine function starts at an axis. Or if it's reflected, it's going to go down first and then up, right? And here's the axis. So, but in either case, sine function begins at the axis, right? What we call a 0, the x-intercept. Whereas the cosine function starts at a max or min. So it's either at a max, like this. Here's the axis. So here's my max. Or it starts at a min because it's reflected, right? It goes like that. And it starts at a min. So let me just show you how you can find all of that in here. So let's say on this top graph, we're going to work on sine. Well, here's, oh, sorry, that's nice. Let me go ahead and put in the axis, which would be at about 2. We could see that. Here's the axis right there. And here's where the sine function could begin, right here, and end. So here's one function on this graph that is sine, right, from here to here. And it's not reflected. Well, let's take a look at another one. I could do instead this here. I'm at an axis, but I'm coming this way, right? And then, so then I'm going from here to here, a reflected sine function. But, you know, I could have instead said, well, I'm going to start here. I'm at the axis, and I'm going to keep going, blah, 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 and keep going. So the point is, obviously, you could find an awful lot of them. You can do the same thing with the cosine function here. I could find the cosine here starts at a max, right? And here's your axis. And here's one cosine wave, right? Or I could start at a min here. And here is a cosine wave, right? And you could keep doing this. I could start at this max, or I could start at that max. I mean, so the reason I go through this a little bit is that when they asked you the question of finding the equation of the graph, they have to tell you, you have to be told, well, where am I supposed to start? Because I could get an infinite number of equations. So this right here is the phase shift. And it tells me where the wave begins. Tells me where it begins. Now, in our case, they're saying between -3 and 0. So what that means is, here's -3, right there, and here's 0. I'm only supposed to look at this portion of the wave right in there, between the two pins. That's where I'm supposed to look for the wave. Now let me go ahead and draw in the axis, just sort of dash it in here for you, so we can kind of look. So I'm looking for a sine function, and remember, sine has to begin at the axis. So basically what we're asking then is, in this portion of the wave that I'm allowed to look at from -3 to 0, right there, where does the graph cross the x-axis? And that's right there. So the wave begins right there. Now, it's a tad smudge off, but they really meant that to be -2. Okay. So the wave begins there, and let's take a look at where does it go to. All right, so here it goes up to its max, comes back down the axis, go down to the min, and back to the axis. Right? So it looks like they intended for it to be at 5. So it goes from -2 to 5. All right. So let's put all this together. What I have is the phase shift, where my wave begins, is -c over b is equal to -2. Right, that's where my wave begins. But what happens here is I have two unknowns and one equation. I can't really solve for that yet. I need another equation. That's where we're going to invoke the period. The period, right, I know is the length from here to here. So let's take a look at the period. Period is end minus beginning. In our case, that's 5 minus a negative 2. So that's 7. So the length of this wave is 7. So the period is 7. But I know the period has the formula 2 pi over b. So I could say 2 pi over b is 7, and that's really 7 over 1. I can cross multiply. 7b equals 2 pi. And so b equals 2 pi over 7. Okay. Now that I've solved for b, I can put this value, 2 pi over 7, right in here. Right? And then I'll be able to solve for c. Now, let me just mention here as an aside that when I plug this in, I'll have negative c divided by 2 pi over 7 equals negative 2 here. So what you have is negative c divided by a number of some sort equals another number. So this is the form that you have. Negative c over some number equals negative 2. Right? If I want to get rid of that number, I'm going to multiply both sides of the equation by that number. Right? So that's what I'm going to do. I'm going to multiply both sides of the equation by 2 pi over 7. Okay. So this cancels out this. That's the reason I multiply both sides of the equation by 2 pi over 7. I'm left with negative c equals negative 2 times 2 is 4 pi, right? Negative 4 pi over 7. So c equals 4 pi over 7. Right? So now we've figured out what b is and what c is. We now have to work on a and k. All right, now, how would I find k? Well, k is how much the entire graph was shifted up or down. And I can see that all the y values they basically fit between what? 1 and 3. So visually we can see the axis is 2, but let's see how we would do that. We'd want to average the maximum y value and the minimum y value. So this point here is 0, 3. That's my max, 3. And then here my min is 3, 1. There's my min, 1. So k is the average of the max and the min values. So if I take max plus min divided by 2, that's what I should get for k. So let's take it, and that is understood y values. So 3 plus 1 divided by 2, 4 divided by 2, 2. So there's a halfway value for the y. And then finally a, you need to look at the amplitude. What's the distance from the axis to the max and the distance from the axis to the min? And what we see is we go from 2 to 3, which is a distance of 1, or from 2 to 1, which is absolute value, distance is 1. So it looks like A is 1. Now we have to decide, is it positive or negative? Well, from where my wave begins, I start going up, which is a regular sine function, not a reflected. So what I know is A equals positive 1. Right? So now, filling in this right here, y equals a sine bx plus c plus k. A is 1 sine, b is, where do we find it? 2 pi over 7. C is 4 pi over 7. K is 2. There you go. So there's the equation of this. Okay. Now, I'll do another example and go ahead and do this with, let's say, cosine, just so you can see from the same graph, but I'll go ahead and put that in another video. Thanks so much for listening.